So the determinant just goes black diagonal minus red diagonal. So what would A times D be in this case? Black minus red. What would A times D be? Negative 12 is going to be my A times D. I agree, because you did 4 times negative 3. Minus, what's this going to get me? Whoops. Yeah, negative 12 minus a positive 12. Oh, it's not as bad as I thought. I thought we were going to get 0. What's negative 12 minus 12? Negative 24. So you guys, that's the determinant. You're like, what the heck is the point of the determinant? We don't quite know yet. You will find out today. Then all we got to do is put 1 over the determinant to make the inverse. So now we're going to go make the inverse. This right here was the determinant. Now you're going to take 1 over that determinant. So we're going to do 1 over negative 24. We're going to multiply that by this flippity-dippity. Look what they did to our diagonals. What they do with the A and the D. They changed their spots. I love it. They flipped them. What they do with the B and the C? Change the sign. Okay, so let's go move 4 and negative 3. They're going to flip them, move their places. Negative 3 goes and down to 4. And then B and C, we got to just change their sign. Opposite of negative 1, opposite of negative 12. 1 and 12, right? Okay. Here's what we got to do. To find the inverse, you just multiply that through. Okay, so we got negative 1/24 times negative 3. That would just get me a negative times negative, which is a positive 3/24, which is the same as 1/8. Boom, boom. What about negative 1/24 times 1? Negative 1/24. I'm going to throw my negative on top. What about negative 1/24 times 12? Negative 1/2. And negative 1/24 times 4. Negative 4/24. 4 goes into 24 6 times. Very good. So negative 1/6. You guys, that right there is the inverse. Whew. Okay. The last thing we got to do. If I were you, let's clear your... you know what? I'm actually okay with you leaving that. I'll write down this next nasty step. So we always have to take the original. My original was 4, negative 1, negative 12, negative 3. Times the inverse, which we said was 1/8, negative 1/24, negative 1/2, negative 1/6. You don't have to write this part down, you guys. Does anyone remember when you take your original times the inverse, what we should get? 1001. What we're saying right now, if this was like 7 times its inverse of 1/7, you always get 1. That's what we're proving right here. Something times its inverse should get us 1, and 1 in the form of a matrix is 1001. Let's go see if that actually works out. You don't have to write this part down because it could get a little gnarly, but I will, I'll write it for you. If you want to write it down and go through it, you're welcome to. Let me just put this here so that we can keep track of some stuff. Okay, you guys, when we multiply 2 matrices together, this 2 by 2 times a 2 by 2, do you agree will get me a 2 by 2? Okay, here we go, people. Top row, left column. Let's take this top row times this left column. We can do this. What would 4 times 1/8 get me, Thomas? 1/2. I wouldn't have called you out if you weren't writing on his board. 1/2 plus, so we did top row, top row, left column, top row, left column. So he said 1/2 plus, what is that going to get when I multiply those together? What's 1/2 plus 1/2? 1. Boom. Let's do this one. Top row, right column, top row, right column. Ooh, don't be scared. 4 times negative 1/24? Negative 1/6 plus 1/6 gets me 0. So this is the way for us to be able to check, like, dude, did I do this right? And it looks so far like we did. Let's double check. Bottom row, left column, bottom row, left column. Ooh, negative 12/8. Anyone want to simplify it? Negative 12/8. Negative 6/4, which is the same as negative 3/2. So this is going to get me negative 3/2 plus plus 3 halves. Negative 3 halves plus 3 halves is another 0. Aight. Last one, bottom row, right column, bottom row, right column. What's negative times negative? Positive. 12/24 is a half plus 3/6 is a half. 1/2 plus a half is 1. So what that tells us is we found the absolutely correct inverse. Whoa, it's a lot. It's a lot. Let's try one more of these with a marker. Okay.
6, 4, 2, -6.
Dig it. Dig it. Let's go see if you can find the inverse of this function. I'm not going to say stuff out loud. I will do it up here. So if you want to double check as you go, you're welcome to. Let's go find that inverse. I found my determinant if you want to take a peek, but don't feel like you need to. This was 9/11 plus, oh, I should have kept it at 20 seconds. My bad. Hold up. Because this was 18 20 seconds plus 4 20 seconds is going to get me what? 22 20 seconds. Final answer, 1. Top row, right column. 6/11 minus 6/11 minus 12 20 seconds, which would be 6/11 minus 6/11 gets me, beautiful. Bottom row, left column, here we go. 6 20 seconds, and I'm only going to leave it as 6 20 seconds because I see that we got more 20 seconds. 6 20 seconds minus 6 20 seconds. Well, what's 0? I mean, bless you. 6 minus the 6 would get me 0. And then bottom row, right column is going to get me 2/11 plus 2/11 plus 12 20 seconds would be the same as 4 20 seconds plus, uh-oh, that one's not coming out right. Oh, golly gee. 22 20 seconds, which is 1. Whoa. Yep, page 41, last question. So, here's what we got to do. In order to solve this matrix, first we got to find the inverse. Here we go. So, you guys, in order to solve this now with a matrix, all we got to do is we got to go find this inverse first. Let's go find this inverse. The inverse of this. Oh, first I guess we should put it like a matrix. Here's how we put this like a matrix. We got to say, oh, this is the same thing as extract the coefficients. 3, 2, 5, 4. That's going to go right here in my 2 by 2. 3, 2, 5, 4. Boom. If I wrote that times xy, that's going to equal my answer, 5, 7. All I just did right there is I rewrote this system as a matrix. Okay? I just extracted my cute little coefficients. Now, you guys, we need to go find the inverse of this to go solve this system. Here we go. Let's go find that inverse. That's what we just did. So, you guys, we got to start with the determinant. What times what minus what times what? Yeah. So, we're going to take that black diagonal minus red diagonal. So, we're going to have 12 minus 10. Final answer for my determinant, 2. Yeah. And then Lebeo's saying, all right, if my determinant's 2, what are we going to put right here, you guys? 1 over 2, which is just 1/2. To go find that inverse, I'm going to take 1 over the determinant, which is 1 over 2, times We got to go to flippity dippity, move my A's and my D's, and take the opposite sign for my B and my C. So I personally always move A and D first. So if it was 3, 4, I'm going to write 4, 3. If my B and C were 2 and 5, they're going to become -2 and -5. Let's go multiply that in to get my inverse. Multiply that in to get my inverse. 1/2 of 4. 2. 1/2 of -2. 1/2 of -5. Yeah, you can just leave it as a fraction. I dig that. 1/2 of 3. You just found the inverse. You found it. You now take that inverse every time, and we now need to multiply it by our answers here, which were 5, 7, and we're done. So what we're going to do, I feel like I should have now I'm going to rewrite it just because it's the first one. That's important. Let's rewrite that inverse. 2, -1, -5 halves, 3 halves. You're going to multiply it by your answers, which were 5 and 7. This is the last step, you guys. This is us solving our system of equations, not with elimination, not with substitution, not with graphing, but with a matrix. Let's think about this real fast. What's the size of this matrix? A what by what? This is a 2 by 2. Be careful. What's this one? Row by column. Yeah, it's 2 rows, 1 column. This is a 2 by 1. Can I multiply them? Yes, because those middle numbers match. I get to multiply it. What's my answer going to be? It's going to be a what? It's going to be a 2 by 1. So I'm going to put those spots for my answers. It's going to be 2 rows, 1 column. And I got that because that's what's left. Whew, it's a lot. This is a lot. This is a lot. We got this, people. This spot. Top row, only column. Top row, only column. Check this out. 2 times 5. 10 plus. 10 plus -7 is 3. You got it. That's my x coordinate. Bottom row, only column. Bottom row, only column. Bottom row, that would get me blank, negative blank over 2. -25 over 2 plus blank over 2. 21 over 2. Final answer, negative blank over 2. -4 over 2. Final answer, -2. Whoa. So these two equations intersect. That was not easy, I agree. At the point, 3, -2. Yeah, I agree. This is not easy, but what is easy is your calculator can do all this for us. And we will learn how our calculator can do it all, but I just want to make sure that we can see that first. So we just found that intersection. Let me say it one more time. You took the inverse, which was 1 over the determinant times the flippity-dippity. You took that inverse times this solution, 5, 7, and that got us where they intersect. Whoa. Let's flip the page. It says go solve it using these matrices. Here we go, people. Let's go rewrite that matrix. This would be 4, 8, 3, -3, 7, 0. Oops. I'm sorry, I left my x and my y out. My bad. This would be times xy equals 7, 0. Guys, you got to take the inverse times the 7, 0. The inverse. The inverse is 1 over the determinant. We don't have to show all of our steps. We now know it's 1 over the determinant. What's my determinant going to be? My determinant is -12 minus 24. Yeah, because it was the black diagonal minus red. -12 minus 24. So did you say -36, Matt Reichert? Beautiful. So my inverse is 1 over that determinant times, don't forget to do flippity-dippities. Move your black diagonal. Change the signs of your red diagonal. And multiply it out. This is really good practicing of just simplifying fractions. Positive 336. What goes into 36 3 times? 12. Now, if you're like, man, I can't do this. I want you to practice it because being an honors pre-calc, I want us to get better at doing this in our heads. But if you're like, man, I need to double check that I did do that right, you guys could always use this alpha y equals tool, negative 1/36 times negative 3. Boop. And then I just want to make sure everyone knows we got that math enter button. Math enter, I do love that button. That'll change any decimal into a fraction. So we got 1/12 times, 1/12, and then negative 8 times negative 1/36. Positive 8/36 4/18, 2/9. Is that what you said? Love that. 2/9. Oh, I like it when they match. We got a 1/12 above that as well. 1/12. 4/30, negative 36. Perfect, Matt. That's your inverse. You take that inverse and you multiply it by these constants over here, 7, 0. We multiply those by the constants, 7, 0. This is going to get us our final answer, which will also be a 2/1. This is the only row, top row, only column. Top row, only column. 1/12 times 7. 7/12 plus 2/9 times 0. 0. 7/12 plus 0. 7/12. Bottom row, only column. Bottom row, only column. I'm going to get 7/12 again plus nothing. 7/12 plus nothing is another 7/12. These two points, these two lines intersect at 7/12.